All right, welcome back to science. All right, so we are, let's see what day we're on here. April Fool's Day, April 1st. Welcome, it's Wednesday. So we are actually gonna wrap up the notes today. And then kind of like last time, all the videos and links and things that are in the notes for today, I'm gonna have you do tomorrow. Just because there are quite a few of them, and I thought maybe it's easier just to do notes one day, videos one day, notes one day, videos one day. So that's kind of the format for this last week here. So again, April 1st, hopefully everybody is doing well, and we are going to start in on slide number 18, wrap up mitosis and start meiosis. All right, so with mitosis, remember, the end result is that you get two new daughter cells. I don't know why they call them daughter cells and not son cells, but the offspring or the identical cells that are created from the parent cell is called a daughter cell. So there's two new daughter cells that are formed that are genetically identical. There are those two words again. Notice how they're in bold. And they are identical to that parent cell and are used to help the organism heal or grow. If mitosis is used in that special category of reproduction, it's considered asexual reproduction, and you get two daughter cells that are formed from a single parent organism, and they are the start of a new organism that is genetically identical to the original. And this is kind of showing the process. You start with one parent cell, it goes through the mitosis cell division process, cytokinesis happens, it splits off, and now you have two cells. Another version, one parent cell, notice how you have the DNA here. Once the DNA replicates, then it is going to go through that whole process that we looked at the other day, and the chromosomes are going to get split apart, and so you have full genetic information here, full genetic information here that's identical to the parent cells that created it. Okay, so the results of mitosis continued. We call the daughter cells diploid cells, and that's a vocab term I'm sure you've kind of been curious about. Diploid is kind of a weird word, but D kind of sounds like double, or reminds you of two, and it contains two sets of chromosomes, okay? So each daughter cell is called diploid, and it has two sets of the chromosomes, and we identify them as 2N. This is kind of a random designation, I guess. The N is just a variable used for the number of chromosome pairs, okay? So pairs of chromosomes or homologous pairs. So there's that prefix homo again, meaning same. And this is going to be very specific depending on the type of species that you're dealing with. So in humans, we have 23 pairs of chromosomes. Now, think of some things that come in pairs, okay? So common things. Give me a second. Usually people say earrings, shoes, socks, a pair of pants because you have two spots, one for each leg, right? A pair of glasses because you have two eyeballs, okay? So things that come in pairs. And so this is, the N is just the number used for the number of chromosome pairs, all right? So here is a pair. And for humans, we have 22 what we call autosome chromosomes, and those are dealing with all of our body functions except for anything that deals with reproduction. The reproduction cells are on chromosome number 23, and they're called our sex chromosomes. And so you have X and a Y, or you have an X and an X, depending on which gender you are. All right, so here we have just kind of a list. Notice how for the animal, it doesn't, the number of chromosomes doesn't match like the size or the complexity of the animal itself. So like a dog is 78 chromosomes, and a pig is 38, humans are 46. So this is our chromosome number, not the number of pairs. This is our diploid number. So we have a total of 60 chromosomes if you're dealing with the buffalo, but you would only have 30 pairs of chromosomes. Okay, so you might have 15 pairs of shoes, which would be 30 individual shoes, if that makes sense. So that's kind of how the diploid works. It's the larger number, it's the 2n. So you take your number of chromosomes, 23 for a human, you times it by 2 for your 2n diploid number, and that's how you end up with 46 total chromosomes. If we're talking pairs, it'd be 23. If we're talking total chromosomes, it's 46. Okay. All right. So let's look at some results of mitosis. Notice there's a ton of videos on this. So those will be linked for tomorrow's information for Thursday. All right, so for mitosis, this allows body cells to grow and replace worn out and damaged cells. We know that, we've talked about that. So like our skin, our blood, lungs, all of the cells in our body except for those sex cells, which would be the egg or sperm, depending on your gender, and we also call those gametes. Okay? So this allows for the continuation of the species if it's used for asexual reproduction. So here it's not reproduction, here it's just fixing, replacing, making new body cells. Here it'd be for reproduction. Sometimes there's issues though. Mitosis isn't a perfect process. And when issues happen, you can get some devastating results. And these, one of the major ones is cancer, okay? It's the timing of how the cells divide can lead sometimes to some miscommunication, some errors. And so if you think about how all these cells have to divide and what they're doing on a every time they have to replace themselves or make new ones, it's amazing that there aren't more mistakes that happen because there's so much involved at one time. And so this can also happen, we can also have errors if the chromosomes don't pull apart properly, the DNA doesn't copy correctly. There's just lots of possibilities or issues that can happen. Lots of, opportunity is the word I'm looking for. A lot of opportunity for issues to happen. So there are 2 videos here that are going to talk about cancer. Unfortunately, I think that most of us have somebody in our life or that we know, maybe not personally, but maybe just a friend of a friend or something like that, or a friend of a relative that has cancer, who has gone through cancer, or we've lost due to cancer. And I think this video here does a fantastic job, the TED Talk, of showing this process of what's going on with the cells and why we get some of the common side effects and things when people do go through cancer treatments. And so it might kind of help you understand the process a little bit more. All right, so we're going to move on and look at meiosis. Notice the ME. This is what makes me, right? And if you're saying it, obviously it's the thing that makes you too. So it's what makes me. You see that in it, ME. And meiosis is special. It only happens for one reason, and that reason is for sexual reproduction. It's used to make new organisms. So it doesn't have anything to do with growth, with repairing cells, with fixing cells, with replacing cells, none of that. It only is dealing with reproduction, sexual reproduction. So meiosis is similar to mitosis because they're both forms of cellular division. However, meiosis only divides the sex cells, the gametes, not the body cells. That's what mitosis does. So meiosis, always think sexual reproduction. And so it's going to combine genetic information from 2 gametes to form something called a zygote. And the zygote has total genetic material from both parents, 2 parents. How many parents did you need for asexual reproduction? Hopefully you said just 1. All right, so the gametes are the sex cell. And again, for the female it's egg, for male it's a sperm cell. I know you guys are probably giggling over there, thinking of these words. Aren't you glad that I'm not staring at your faces and you're more uncomfortable and awkward than it has to be? Right. Enjoy your video in silence and alone, I guess. So here's some advantages. Just like we had advantages for mitosis, there are advantages for meiosis or meiosis. Greater variety of genetics in a population. Well, we already spent last unit looking at adaptations and variations, and if an environment or climate changes, sometimes if you have an organism that has something different than the rest of them, that's going to become an advantage. So this is how it happens. Meiosis is the process that gives this genetic variety and variation, and then those things can lead to adaptations at times. It's better at adapting to an environment or a climate if it changes. It also leads us to new species. Think of Darwin and his finches, right? And half of the genetic information comes from each parent. So if only one of your parents is healthy, then there's a chance that you're going to get more of the healthy information than the unhealthy information, I guess, is kind of a simplistic way to look at that. So you get 4 haploid cells that are produced with only half of the genetic information. We'll talk about that more a little bit. But we had the other word diploid, meaning double, like 2N. Haploid is going to be half of the information. And think about it, if you get all the information from one parent and all the information from the other, you'd end up with double the information, and you don't need that. You only need half from one, half from the other, so when it comes together, you have all the information. Half and half makes a whole. Okay? All right, so meiosis. Actually, it's broken up into meiosis 1 and meiosis 2. Again, I'm not going to say what specifically happens at anaphase during meiosis 2. I'm not going to do that, but I want you to just have the general idea of what's going on with the cells. So the chromosomes are going to replicate. The chromatid begins to condense. Okay, so it goes from that hairball DNA to forming like the X chromosomes, right? Those X-shaped chromosomes. And so during prophase 1, the chromosomes will condense. The homologous chromosome pairs up with one another. Okay, so during metaphase, the nuclear membrane starts to dissolve. The homologous chromosomes attach to the spindle fibers, and the chromosomes move to the opposite ends of the cell. So basically, the same thing that happens during mitosis happens during meiosis 1. And then telophase 1, the cell begins to divide into 2 daughter cells. So far, exactly like the process of the mitosis cell division. Here's where it changes. It goes through a second cell division, or second division. And so the cell is going to have those 2 daughter cells that are now going to start to divide again. And so just like in meiosis 1, the chromosomes are going to line up on the spindle fibers. And the 2 cells begin to divide. And just like in meiosis 1, the chromosome moves to opposite ends of each cell. And then you get 4 new cells that are formed. And I'll show you some visuals of this here in a minute. The key here is that you started with 1 cell and it went to 4 daughter cells that each carry half of the information. And this is what it can kind of look like. You end up with the new organism from 2 parents, and each parent had 4 daughter cells that were haploid cells that formed. And we identify them as N, not 2N. So N is just that variable, right? It's used to represent the number of chromosome pairs present. And it's talking about 1 full set. So haploid is half of the genetic information. Diploid is double or the full set of information. So diploid goes with mitosis and haploid goes with meiosis, because again, you want a brand new cell to have all the information if it's a body cell or if it's for asexual reproduction. You only want the cell to have half of the information if it's going to join up with another parent cell that has the other half of the information, okay? And so we end up with 23 single chromosomes in humans, okay? And that is our haploid number. So the way I think about it, haploid always means half. It's always going to be the smaller number. So if I would want the haploid number for a human, it's 23. If I want the diploid number, it's double that because it's 2N to like multiply your 23 times 2 to get your 46. And usually that's the easiest way to remember it. Haploid is half because it's having half the information, so it's N. Diploid sounds like double, so it's 2N. It's the larger of the numbers. Okay, so with meiosis, it also isn't perfect, and there can be some issues that arise as well. Sometimes chromosomes get damaged, deleted, or altered, and this can lead to genetic disorders. These can get passed on from generation to generation because they are linked to the sex cells. So that's why it's hereditary. Any cell can have a disturbance, right? It can get mutated or messed up during mitosis. But that's not going to be a genetic disorder. If it's linked to those sex chromosomes, the egg cell or the sperm cells, when they start to divide, that's when you get disorders that are passed on from generation to generation. Also, this can result in something called Down syndrome, which is an extra chromosome. I believe it's on chromosome number 21. And so think of it as having too much information. So you think, oh, having more chromosomes, that'd be a good thing. Well, think of having like a set of instructions and then you get a whole nother set of instructions. They kind of like interfere and cross over. Do I follow this set? Do I follow this set? Do I follow both sets? And so things get confused, okay? And so these random mutations can cause variations in the DNA. These variations can be good, they can be bad, or they can have no effect at all. So like sometimes somebody might be born like with no pinky. Well, is that really going to affect their life? No, it's just kind of neutral. Like it's not good, it's not bad, it's just different, okay? So that's one thing that sometimes we forget, that sometimes these things are just like, yeah, it's a difference, it's a mutation, it's a variation, it's different, but it doesn't help or hurt. Sometimes things can obviously be very bad, like if there's a defect like with the baby's heart as it was forming. Sometimes things can be good, right? And so it just depends on the actual mutation that happens. And so I have a couple of videos here that you will watch on your next session. All right, so again, the only thing meiosis is used for is for sexual reproduction, where you get an offspring that is genetically similar to the two parents. Similar, not identical. None of you are identical to your parents. Okay, you had shared DNA, but you have differences as well. And so this also goes back to Darwin's survival of the fittest and natural selection. He didn't know about all this genetic stuff. He just made observations and saw like variations and changes, and he didn't know how that happened, but he observed them and he's like, wow, because of these changes, this is what's happening, right? The survival of the fittest and natural selection. But he didn't have an explanation of how it happened. So it's pretty cool that he kind of had the beginning part before he even knew the background. So pretty impressive, honestly. And we know that biodiversity is going to exist because of this meiosis process. So this is a key idea. So definitely need to realize that meiosis is what's responsible for our diversity, our variations, and all of that. Okay, so just kind of an overview. Here's meiosis. You start with the full amount of chromosomes and DNA. Then it replicates. So now you have twice as much. It's going to separate into two daughter cells, and those two daughter cells are then going to divide themselves, so you end up with 4 haploid daughter cells to end the process of meiosis. Mitosis stops here, right? It doubles the DNA, and then it splits, and so each cell has the full amount that it needs, right? These are 2 diploid daughter cells. These are 4 haploid daughter cells. All right, so you have to keep that straight. There's a few things, and I'm hoping that these will work for you. If they don't, that's okay, don't stress about it. But these will show the process of meiosis and mitosis a lot better than I can. These are the notes, these are the words, but looking at these links tomorrow, hopefully we'll kind of put all this together for you. There's a lot of cool links and things that are available for this topic, so you can spend some time tomorrow looking through those. Okay, put a big old star by slide number 31. You are going to need to know this. This chart is going to be very helpful to you. It organizes everything nicely. So, with meiosis and mitosis, all right, so the type of reproduction, and if you want to pause me, obviously at any of the times throughout these notes you can pause me, but if you want to, try to think of the answer before I say it, that's also a good way to kind of test it yourself to see where you're at. Obviously, we haven't done a bunch of practice with this yet. That's coming. So again, this is one of those topics where it's important just to kind of get you the information, and then because it's all kind of related, it's hard to isolate practice. So now that we have all the information, then we can start practicing. But if you want to pause me, I know you'd love to do that in real life, mute me. but go ahead and pause me if you want to try to answer. I'm gonna go ahead and just kind of keep going through these so that you get the information. But feel free to work at this at your own pace. So meiosis, we're gonna look at the type of reproduction. So asexual or sexual. Meiosis will be using sexual reproduction, so then that means mitosis would be asexual. The type of cell that's produced. So we are looking at the haploid or diploid, I believe. Oh, sorry, yeah, okay. So haploid or the gamete, so we're dealing with the sex cells. So this is gonna be half of the genetic information. And then here we will have the diploid or the body cells. So our options are haploid, diploid for the half amount or the double or full amount. And then the gametes are the sex cells, and then every other cell in our body would be the body cells. Number of chromosomes in a new cell. So this is for humans. So we're going to say 23 total chromosomes. Double that, diploid, is 46. And then we represented the haploid number as n because it was half, and then the diploid as double or 2n. The number of cells produced at the end would be 4 haploid daughter cells, 2 diploid daughter cells. Because remember, meiosis had to go through one more division to split it, split those 2 daughter cells one more time, so that you can get it down to the half amount. 2 parent cells to 1 parent cell. And here's those key words again: genetically identical, genetically similar for our meiosis, and then genetically identical. So this would be cloning. This is asexual reproduction, that budding, that fission examples. Here's how most organisms that we're familiar with have reproduction. Right? They're going to be just genetically similar. Okay. Again, this chart is very important. Put a big old star by it. This is basically all the information from this unit kind of summarized nicely. Notice, you can't just say, oh, the mitosis is always going to be the big number. It's the big number for this and this, but it's the small numbers for these two. So you can't just say, okay, mitosis will always be the big number, meiosis is always going to be the small number. All right, so you can't think of it that way. Try not to memorize this stuff, but just kind of like walk yourself through the process and like think about what you know. Right, half haploid. That means this stuff is going to be small. But then what's produced is 4 daughter cells, because each one of those cells is going to have half of the amount. Okay, and then obviously with sexual reproduction, you need 2 parents. So don't try to memorize. Think logically about what you know. And then there are a ton of websites here. I'm going to put these links so that you can read. These are some common questions that people have about genetic stuff. And so I will put these links in there and you can take a look at those. And then this is actually a Snurfle activity. Snurfle, yes, I just said Snurfle, it's a weird word. A little activity game thing. Depending on time, if you get to that, maybe if we're still out of school here in this 4th week, that would be something that would be coming. But I will post these. These are, again, I'm not quite sure if these will work for you. I think they will, but it shows the process of meiosis and mitosis, and so good visuals. And then these are just some questions that people typically have from this unit. So read that or watch the videos. This is a pretty cool video about conjoined twins. It's kind of long, but it is interesting. So I'm not sure, I might post that on a separate day. I'll just wait and see kind of how things are going. So I hope everybody is still doing great, or if, at this point, you should be, well underway with understanding how to do all this. Again, if you have questions though, please make sure you email me and let me know, and I will get right back with you. So take care, be healthy, be well. This was wrapping up the information on Wednesday, April 1st. Have a great April Fool's Day. See ya.